Okay, so continuing on. That was a lot of work, right? Making a table of all of those points, finding each individual value of r from each theta. It's a lot of work. So one way to make it a little easier is to look at the symmetry. You could have symmetry with the respect to the line theta equals pi over 2. That's this vertical line going up and down here. So you could have symmetry across that line. You could have symmetry with respect to the polar axis, which is the horizontal line right here. Or you can have symmetry with respect to the pole, or the origin. And that looks like this. So 3 different ways you can have symmetry. And there are some nice shortcuts to look at that. If you say plug in negative r and negative theta, and that equals your original equation, then you have symmetry about the line theta equals pi over 2. If you have, when you plug in positive r and negative theta, if that's the same as your original equation, then you have symmetry about the polar axis. And if you have, if you plug in negative r and positive theta, then you have symmetry about the pole, if those two equations are the same. So we can look back at r for r equals 4 sine theta and check to see what kind of symmetry does it have. Oops. What kind of symmetry does it have? So first, let's check symmetry with theta equals pi over 2. So it's negative r and negative theta. So I'm going to plug in negative r and negative theta. Keep in mind your even and odd functions. Sine, tangent, and cotangent and cosecant are all odd functions. So sine of negative theta will equal negative sine of theta. And this is true for sine, for cosecant, for tangent, and for cotangent. They're all odd functions. Cosine is an even function. So if we were to plug in cosine of negative theta, we would just get cosine theta because it's even. And cosine and secant are the only ones that do that. So you got to keep in mind the even, odd trig functions. So 4 sine negative theta becomes negative 4 sine theta, and then I can divide out these negative ones from both sides, and you get r equals 4 sine theta, which is the original equation. So we know we have symmetry about the line theta equals pi over 2. We can check the other two just for fun, but we know we will not have symmetry about the other two because we already found our symmetry. If it were to have symmetry at the polar axis, r negative theta, so we just plug in negative theta and we keep r positive. So 4r equals 4 sine negative theta. And again, throw that negative sign in front. R equals negative 4 sine theta, which is not the same as our original equation. So we do not have symmetry about the polar axis. And if we wanted to look at symmetry with the pole, we would say negative r and theta. So negative r equals 4 sine, that should say positive theta. And what that does is we're solving for r, so dividing out that negative 1, we get r equals negative 4 sine theta, which is not our original equation. So the only symmetry we have is about the line theta equals pi over 2. What does that mean? If here's our polar graph, here's our line, theta equals pi over 2, that means all the points on the right side have to match up with the points on the left side because it's symmetric. So how can we use this? Let's look at example 3. So looking at example 3, we want to find out what type of symmetry it has. The equation is r equals 3 plus 2 cosine theta. So first I'm going to check, does it have symmetry about the line theta equals pi over 2? In order to do that, r is negative and theta is negative. So plugging that in, you get negative r equals 3 plus 2 cosine negative theta. But because cosine is an even function, that doesn't matter. So we end up getting negative r equals 3 plus 2 cosine theta. Or we can say that's negative 3 minus 2 cosine theta. That's what r is going to equal. That is not our original equation, so this is not the type of symmetry we have. Let's check the other kinds. We can say positive r comma negative theta. If we plug in negative theta but keep r positive, we're going to end up with our original equation, r equals 3 plus 2 cosine theta. And that is the polar axis symmetry. That is that horizontal line symmetry. So what does that mean is, here is our polar axis, right? This line here. So all the values above it have to match up with all the values below it because they're symmetry. So above it would be 0 to pi. So you only need to find the values for 0 to pi, and then you can repeat them below because they're going to be the same. So I plugged in, again, our equation is r equals 3 plus 2 cosine theta. So for example, plugging in 0 for theta, I would say 3 plus 2 cosine 0. Cosine of 0 is 1. So this is 3 plus 2 times 1, which is 3 plus 2. And that gives you 5. So r would equal 5 in this case. And continuing on all the way from 0 to pi using 30, 45, 60, and 90 degrees. I get my table that I made here. And I'm going to graph these points. So when theta is 0, r is 5. So that's 1, 2, 3, 4, 5. When theta is pi over 6, r is 3 plus root 3, which is 4.7. So pi over 6, r is 4.7. 1, 2, 3, 4. So almost 5. When theta is pi over 4, r is 3 plus root 2, or 4.4. So that's going to be about here. When theta is pi over 3, r equals 4. When theta is pi over 2, r equals 3. We're going to hop over here. When theta is 2 pi over 3, then r is 2. It's down here. When theta is 3 pi over 4, r is 3 minus root 2, which is 1.58. So like 1.5. When theta is 5 pi over 6, r is 3 minus root 3, which is 1.26. So it's even closer to 1. And when theta is pi, r is 1. So that's right down here at the lowest. That's half of it. So then we could continue the other way. So if we're going down, we hit the 30-degree angle, pi over 6. That would be 11 pi over 6. That would be the same r value, 3 plus root 3, or 4.7. So I can say it's going to be here. At 7 pi over 4, that's the same r is pi over 4, 3 plus root 2, or 4.4. So that's going to be about here. At 5 pi over 3, that's the same r is pi over 3, or 4. At these are a little off. So at 5 pi over 3 is at 4. And right, 1, 2, 3, 4. And then we have a little higher and a little higher here. And then it's going to be 3 at 3 pi over 2, because 3 pi over 2 and pi over 2 I'll give you the same r. Also, 4 pi over 3 is going to give you the same r as 2 pi over 3, which is 2. So that'll be down here. And 5 pi over 4 will give you the same r as 3 pi over 4, which is 3 minus root 2, or 1.58. So that's 1.5. And lastly, 7 pi over 6 gives you the same r as 5 pi over 6, which is 3 minus root 3, or in decimals, that's 1.26. So that's down here. And we're going to connect these. I'm going to connect them blue. And what you see is we have this small point, and it's going to get bigger and bigger until you reach your largest point. It's going to come back down smaller and smaller. And we have this kind of circle, except it gets this little divot here in the middle. We call it a dimple in graphical terms, and it comes out and around, almost like a heart. And this shape is called a limacon, L-I-M-A-C-O-N, and the C has got a little accent underneath, a limacon. So what you're going to see with graphing these polar equations is you're going to get some really interesting curved shapes. And we will stop here for part 2 and continue on with part 3.